For the next topic, we have general equation of second degree conic section. So we have, of course, four conic sections, second degree conic sections. We have circle, parabola, ellipse, and hyperbola. Of course, we will not be including the line because that is not a second degree. That is only a first degree conic section. So for the model equation, you'll have your ax. Let me zoom it so that you guys can see it better. So you'll have your ax squared bxy plus cy squared plus dx ey plus f. Okay, so as you can see, the difference here now is you'll have an xy product, but we have conditions here. Okay, we have conditions. So the conditions are, you will have a test of b squared minus 4ac, that is called the discriminant. So for number 1, if b is equal to 0 and a is equal to c, that will be circle. If the discriminant is equal to 0, it will be a parabola. And if the discriminant is less than 0, ellipse, and the hyperbola if it's greater than 0. Okay? And then there's another topic is elimination of product xy. So if you want to eliminate the product xy, this product xy, there will be an angle of rotation which is tangent 2 theta equal to b over a minus c. Okay, and then we have a condition for that, which is the theta must be, or 2 theta must be 0 to 180 only, and if it's theta, all you have to do is just divide everything by 2, and then theta will be, the value of theta will be 0 between 0 to 90. Okay, it cannot be 90 because the tangent 90 will be equal to undefined. So relation for substitution, you'll have x is equal to u cosine theta minus v sine theta, and y will be equal to u sine theta plus v cosine theta after the rotation. So let's move on to, let's try some problems. So for number 1, we will have given the equation of 2x squared minus square root of 3xy plus y squared equal to 2. Okay. So by comparison, as you can see, your a will be equal to 2, b is equal to negative square root of 3, and your c will be 1. Okay, so let's try now to letter A, identify the curve. Therefore, we have to use the discriminant b squared minus 4ac, which is b is equal to negative square root of 3 squared, and then minus 4 times 2 times c is equal to 1. So this will become 3 minus 6. Right? So this is negative. No, that's negative, not negative 6. It is negative 8. So this is negative 5. So it is less than 1 actually. Less than 0 actually. So negative, so less than 0, it will be this one. So therefore, this is an ellipse. Okay. So for number 2, no, not number 2, sorry. Letter B. Letter B. To what angle should the axis rotated to eliminate the product term xy? So we have to use the angle of rotation. So angle of rotation is tangent 2 theta equal to b over a minus c. So this is 2 theta must be equal to arctan, right? Arctan of b over a minus c. So to get 2 theta, you'll have here arctan b. B is negative square root of 3, a is 2, and minus 1. So if you will get the answer here, so 2 theta is equal to negative 60. That is only the 2 theta. But as you can see, the condition here is the 2 theta must be 0 to, the value of 2 theta must be only equal to 0 to 180. So what you're going to do here is, you have to rotate this one, or get the mirror of the value. So if this is a Cartesian plane, right? This is a Cartesian plane. Okay. So let's say that's negative 60, so that is must be on the fourth quadrant. So this is negative 60. If this is negative 60 or 60, not negative 60, this is 60, therefore I can also say that this is 60. Okay, and then of course this is 90. If this is 60, therefore this is 30. Okay, so if this is 30, this is 90, therefore the mirrored angle of the negative 60 will be this angle, which is 90 plus 120, right? Therefore we can also say that the 2 theta will be equal to 120 degrees, and then theta now will be equal to 60 degrees. So this is the answer, 60 degrees. So you have to rotate the angle of rotation will be 60 degrees. So for letter C, find the equivalent of the equation of the curve without the product term xy. Okay, so you can just use the relation. Okay, I'll just write it down again. So for letter C, the relation will be x will be equal to u cosine theta minus p sine theta. But we all know that we were able to compute for the theta, which is 60. So this is u cosine 60 minus v sine 60, or this will be equal to 1 half u minus square root of 3 over 2 v. So this will be your x. How about for y? So y will be u sine theta plus now plus v, no, not sine, cosine 60. No, theta first, theta. So substituting, so you'll have your u sine 60 plus v cosine 60. So, and then getting the value of sine 60 and cosine 60, you'll just have here square root of 3 over 2u plus 1 half v. Okay, so with that, all you have to do is, where is the equation? Substitute those values. This is y, right? Substitute these values to the original equation, which is 2x squared minus square root of negative 3xy plus y squared. Okay, equal to. Okay, so let's substitute the values. You'll have here 2 times x squared, so that will be 1 half u minus square root of 3 over 2 v squared minus square root of 3 times the value of xy, right? Xy. So x is 1 half u minus square root of 3 over 2 v. That is x. And then for the value of y is square root of 3 over 2 u plus 1 half v. And then plus now y squared. So this will become square root of 3 over 2 u plus 1 half v squared equal to, and then all you have to do is just do it algebraically, and then for sure that you won't have any xy term any longer. Okay, so I won't be doing this this because this will be too long, so you can just do it algebraically on your own. But for sure you will end up with something like u squared, uv, and v. Okay, so let's move on to the next topic.